Hey guys, welcome to your lesson on physical and chemical properties and changes. So, physical properties can be observed using your five senses and help you to identify a material and determine how it can be used based on your five senses. Examples of physical properties are appearance, so how it looks, it's how it feels, its texture, color, odor, melting point, boiling point are also considered physical properties, which can sometimes be confusing because melting and boiling something, you might think that you're really changing it, but you're not, because if you think of water, you think of an ice cube. You melt an ice cube, it's still made of water, and if you boil water, it's still made of water, even though it looks different. Density, which density is mass over volume. There's nothing chemical there, it's just a measurement. Solubility, so how easily something dissolves, taste, and many others that you can use your senses. Again, melting and boiling points are both physical. So melting point is the temperature and pressure at which a solid becomes a liquid. So when ice turns into water, that's melting point. There's a specific temperature at which that happens. And then boiling point, the temperature at which a liquid becomes a gas. So when you're boiling water for noodles or something and the bubbles start to form and then the steam happens, that's when the water is going from the pan or the pot into the air as steam. Chemical properties, they describe how something will change into something else, and substances only change into other substances by reactions. Sometimes these aren't easy to observe. For example, metal rusting. You have noticed that metal has rusted, but it's not easy to actually see the metal rusting because it takes place over a long period of time. Examples of chemical properties. Reactivity is a chemical property that describes how an element or a compound reacts with other things like oxygen, acids, or even water. So how likely is something to react with something else is reactivity. And if you think of the periodic table and you think about valence electrons and how many valence electrons an atom has, if you're talking about something that's in group 18 and there's 8 valence electrons, it's going to be considered non-reactive. It does not have a high reactivity because its shell is already full. Whereas if you think about any of the elements in group 1 of the periodic table or group 7, they don't have full shells and they want to have 8 in order to be full, so they are going to react. So they are reactive. And then different things react in different ways and react with different substances. Flammability just means the ability of something to burn. So substances all have chemical properties, even though you can't see them. This song, which you can't click here in the video, is posted underneath this video on the website, and it's a great song to help you understand the difference between physical and chemical properties. All right, physical changes. Now, physical changes are what the substance is made of. When you have any kind of change, the substance itself does not change. So if you take a piece of ice or a piece of chalk, for example, and you break it in half or you break it into a bunch of pieces, it's still ice and it's still chalk. There's nothing chemically changed about it. So getting a haircut, your hair is still made of hair. Nothing chemical has actually changed about your hair. Physical changes. So after a physical change, a substance might look different, but it has the same atomic structure. It's important to remember that all changes of state, so from a solid, a liquid to a gas, all changes of state are physical changes because the identity, what the substance is made up of, stays the same. So remember, when an ice cube melts, it just melts into water, and ice and water are made up of the same thing. One that's kind of hard to remember or to keep straight is dissolving. So when you dissolve, for example, sugar in your sweet tea or when you dissolve a little drink packet that we have at camp, when you dissolve that in water, that's a physical change because the sugar molecules or the the drink molecules in the drink packet, they don't actually change. So if you were to evaporate your liquid drink, that sugar or that drink packet would be left behind. So they're not actually chemically combining, they're mixing together, but you can unmix them. Even though they look completely chemically combined, they're not. So physical changes in matter, so cutting something, tearing something, folding something, writing on, painting, solid liquid gas, any kind of mixture or any kind of solution where you dissolve something in something else. Those are all physical because it's still the same substance. All right, again, here's some pictures of some physical changes. The first one in the top left is sanding. So when you sand a piece of wood, you might be changing its shape, but in its texture, but it's still made up of wood. Chemical changes are when a substance changes what it is made of by bonding with something else, another substance. In a chemical change, you might notice a change in smell. You might see fire or light or something rusting. Examples of chemical changes, digestion. So we spent some time on human body systems, and when you eat food, it starts off outside of your mouth and it's in your mouth, and immediately the acids and the enzymes in your mouth start working on your food, and then the acids in your stomach start breaking it down even more. Baking a cake, you cannot unbake a cake. When milk goes bad, you can't make it go back to its original state. A campfire, you cannot unburn a campfire, and fireworks, you cannot unexplode fireworks. So if you cannot reverse it back to its original state, it is most likely a chemical change. So chemical changes make new substances that have different properties from the original ones. So I like the cake baking example because it's easy to understand. So when you first bake a cake, you start with several different ingredients. After it's done baking, though, all the ingredients are mixed together and look very different from what you started with. So chemical changes are also known as chemical reactions. When you bake a cake, you have flour, butter, sugar, milk, all sorts of different ingredients that when mixed together is not easy to see what the original ingredients were because a chemical reaction has taken place. Chemical changes are pretty easy to see. When you bake a cake, it's easy to smell that. In the science lab, now we wouldn't stick our nose up into something because it's not safe. We can see color changing, we can see fizzing and foaming, that's pretty common, or heat and light. And with the cake, you can see the batter is hardened into cake, and you can smell it, and sometimes you can hear it being cooked. If you're listening for it, you can kind of hear the ingredients bubble. Chemical changes cannot be reversed by physical changes. So you cannot unbake a cake by separating the ingredients. However, there's very few instances when you can reverse a chemical change, and they're not done easily. So one example that I'm going to give is water. You can split, so water is H2O. There's 2 hydrogen atoms and 1 oxygen atom, and it's a molecule. They are chemically combined. And you can actually split the H and the O using an electric current to start a reaction. And this is what it looks like. You hook it up to a battery, and the little tiny bubbles at the bottom, that's O. So they're actually taking the oxygen out. But again, it's not common to be able to reverse or undo a chemical change.